So, in summary, what we do is focus on this, just data filtering and cleaning, and then here, data processing, just transform, normalization, imputed, and then summarization, and then here is the final inference stage. Basically, our goal is compared between the group. Our hypothesis is there any difference between the groups or not? So that is our focus. And then in this case, we use group comparison functions. So what this group comparison does is find the experiment design, and then based on your experiment design, find the best model in current stage. And after apply this, and then FDR correction we made, and then if there is some specific case, we flag the specific case. So specific case means maybe it can be related to the some missing cases. So if you just think about our profile plot, so let's say this is a protein 1, here is the condition 1, and then here's the condition 2. If we have some profile plot like this, we can summarize value here. We can compare these two. Special case 1 is condition 1, condition 2. There are several feature measures, but it's completely missing. No missing value. We are not gonna impute it because there's any reference value at all, right? So here, we have a condition. And then MSstats said it should be p, or just the p-value is 0. We just record 0, which means it looks something happened, but we cannot give you any statistic number. That is what we say. So we flag this one too. Or special case, no measurement at all. For example, there are more than 2 conditions, and actually there are 3 points for each feature. So based on our filtering strategy, we have a 3 measurement across the MS plot. So we passed, and then we keep this. However, if summarized here, 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 we have only 1 value per condition. We have only 1 value per condition, and we cannot give you any statistics. We cannot compare 1 versus 1, how they are significantly different, we cannot say because there's no variance, right? So this is a special case too. So this kind of case will be reported in this stage. So group comparison function is very simple. Actually, 2 input we need. One is output of the data processing. Second one is what kind of the comparison you want. So here is what I said, assign the contrast matrix. So this is actually MSstat cannot do. You actually made by yourself. So rule is we need to make a matrix based on your condition. So our goal is we are gonna make a matrix, like the data table. The column should be our condition information. So in our case, we have a 4 condition. So we need a 4 columns. And then each row, we are gonna say which condition and which comparison you want. So let's say first we want condition 1 minus condition 2, we want to compare, right? In that case, how we can assign this? 1 minus 1, 0, 0. basically the condition is not related to your interest, just put the 0 and then put the constant for your interest condition here. So let's say if you want to compare condition 2 minus condition 1, so here actually 1 times condition 2 plus minus 1 times condition 1, right? So it should be minus 1, 1, and 0, 0. It makes sense? Then let's do this advanced stage. Condition 2. Here. Condition 2 plus condition 3 divided by 2. So basically average of these two conditions versus condition 4. You can make this one too, right? Let's make this equation like this. 1.2. I just rewrote this equation. Right? Then it should be 0.5. It should be 0. 0.5. 0.5. And minus 1. It makes sense? Okay, yes, blue note, and no is yellow. If you get too much yellow, I will practice another video. Okay. I will talk about it. Okay. It makes sense? So, the reason why this is important, when you interpret our last estimate for changes, this is better, right? Plus minus up, radial up or down is depending on this plus minus sign. Okay? Make sense? So let's try to do in R. So here I will use the skyline output for group comparison. So first we need to set contrast matrix. So if you already practiced in intro R, I think you are okay for this. So I said first my comparison, I want to say matrix and C, and I want to make a first row. So here should be 1, minus 1, 0, and 0, and it should 1 row. Right? So I just exactly make the first row of that matrix. Okay, then I will make another comparison 1, 0, minus 1, 0. That means condition 1 minus condition 3 comparison, right? So now we have a 4 condition, 1, 2, 3, 4, right? How many pairs we can compare? How many pairs we can make? 1, 2, 3, 4. So 4 times 2 divided by 2, so total 6. 6 pairs we can make it, like 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4, right? Let's fill in the 6 other 4 comparison here. This is a small challenge. Yes?
So there's no difference between comparison 1 minus differential 1 minus differential 2
Yes, only difference is just plus minus sign for estimate for changes. So here's the challenging. So please fill in other 4 more pair comparison. Right, so for example, if you have a time point 0, 1, 2, right? It's up to you, but most likely 1 minus 0, 2 minus 0.
So it's common compared to
First one, yeah. So let's try. So here is matrix C, same thing, but 1, now 1 versus 4. And next, so 1 compare with all 3. So let's skip 1. And then now, second one and third. And here, second one versus fourth. Yes, thank you. So now 2 is gone, and then here. Alright. So all 6 done. I will select all. I will run. Right? So now we have a 6 matrix with 1 each row. Then I will make this is just 1 matrix. So I will make combine, comparison, are bind, right? And then now comparison has this matrix, right? Okay, now I fill in the matrix, but I want to say, so basically how I can label this case. So what I will do here, I will assign the row names of comparison. First, condition 1 minus condition 2, right? Second one is condition 1 minus condition 3. And next one is condition 1 minus condition 4. The other one is condition 2 minus condition 3. Condition 2 minus condition 4. And condition 3 minus condition 4. So I will run this. Then finally our comparison matrix look like this way. So this will be labeled for our final result. Okay? Then here's our functions. So test skyline, group comparison. The input should be output of the data processing. And then contrast matrix is comparison. What we made it just before. and then I run, and then here sub progress here. So it will take less than data process. If you have any error message, please put the yellow one. No, red one.
Can this command use the clusters to speed up?
I don't remember.
Just try.
Yes, but I don't think so. Yeah,
Cannot.
yeah. Because the reason was when I made out this one is available for cluster. For memory, there's some memory issue for laptop, so it should be work for your other computer, desktop or something. But for laptop, actually, the memory was really big issue, very frequently. So I just stopped to make this one as a cluster. Sorry about this warning message, but you don't need to worry about it. That's fine. So people have the 100%. Please put the blue one. I'm just wondering, I have to wait a little bit more or not? Okay. So then let's see what it include. So same as the data processing, the output of the group comparison function, here the data skyline, that test skyline have a multiple information. So let's double check what information it has. Test skyline. There are 3 different data include. So let's check the first one, the test skyline dollar comparison result. This is the main output for these functions. So here, I will run this one again. Here, for each protein, for each comparison we assign, here's the estimate of 2-4 change, and standard error, and p-value and degree of freedom. And then here is the p-value, and then after adjust the p-values. And then here's the issue column. So if they have any issue like this, they're gonna say something. And then here is missing percentage and imputation percentage. So how many features or how many measurement is imputed? So here, number of missing percentage and imputation percentage might be different if we can distinguish random missing and censored missing, or some specific run is completely missing. So that is the first one. Second one is fitted model. So basically for each protein, we fit the model, and then this is saved what was the final result for after fitting the model. So people who actually advanced level and they want to look at this one. So here is the final, the fitted model. But mainly people can just use this comparison result. So then after I got this, let's save the comparison result into the another data. So test skyline 2, test skyline 1, comparison result. And how the test skyline 1 look like. Is same as what we see before, just the protein and condition and estimate for changes and p-value and so on. If you want to save this one, you can save as R file, or if you want to report or share this one to other people, you can save this one is as a CSV file. Okay. Then let's try to make a visualization for our result. So after data process, we use the data process plot. And after that, we use group comparison, and then we will use the group comparison plot functions. Okay? So group comparison, but here, if I type here, I can see the group comparison functions. There are 3 different plots are provided. So first, we need to put our result. Here, and what kind of plot do you want? I want to draw the volcano plot. And where? Under the data skyline, then I will go back to the folder data skyline. Here I can find a volcano plot. So volcano plots are drawn by each condition. So first plot for condition 1 versus condition 2 comparison, this is the result. So here x-axis log 2 for change, y-axis based on adjusted p-value, and then we transform minus log 10, so it should be completely opposite. So higher value means more significant, lower is not significant. Here is the cutoff for 0.05, so less than this means not significant. Higher than this line is significant. And then there are 2 types of the color. Red is upregulated, blue is downregulated. And then here, so we just name it. You can change the font size for letter. You can change the font size of the dot. you can remove this protein name if there are too many proteins around here. You can completely remove it. You can change the size and so on. So here 1, 2, 3, 4, 5, 6 proteins for the specific comparison, right? Let's double check this is the correct ID, what we expected. So if I come back here, 4405. So 4405 is not here. So we have a 1 false. And then 55752, 55752 here. And then here, especially his Q2771, actually this is should not changes, right? So we can see so the test result, and the next plot is compared to other comparison. Here we have only 4 significant, which should be 6, and then here's also 4, and so on. So here is the summary of the whole the testing result. And then next one is comparison plot. So this is quite similar as the condition plot. But before I click yes, if you enter here, try to run, actually comparison plot will draw by each protein. So it will take for a while. So I will just type which proteins, and then I will copy one of the protein name. So I missed the comma here. Then here I have a comparison plot. So here x-axis comparison ID, y-axis estimate for log 4 changes. So here's the 0 means not changes, they should be saved. And then for each comparison, here's the estimate for changes and the standard error, and so on. So if error bar like this, maybe this is not kind of the 0 values included here. But if this case and this cases, you can see this is quite significant different. So this is different than condition plot. The condition plot was for each condition, but here is for the compare between these two. So here value is completely, this is a log 4 changes, and then condition plot is original log 2 intensity values. So it will be different. The one other example where people use this one a lot, for example, time course design, they made a comparison time point 1 minus 0, 2 minus 0, 3 minus 0, and 4 minus 0, means this one can be time. And then from 0 point, how much they can change it. And then with the error bar. So this is quite common for time course design, and the summarize the result one. So that is the comparison plot. And then next one is the heat map, but at this moment I will skip this. But before we move on to other case, let's play a little bit how we can extract, like just doing some subset things. So if you remind, test Skyline 1 has our test result. And then here, whole result, I want to subtract only significant proteins. So I said significance skyline test is from test skyline 1, and then I will put the condition here, test skyline 1, and I will check the adjusted p-value. Adjusted p-value is less than 0.05. So basically, I subtract the row which has adjusted p-value is less than 0.05, and then make another subset of the data. So it should be, between this square bracket, comma, and then condition should be in the row. And now I can see here our significance skyline. We have a 28 observation. So we have a 6 proteins and 6 comparison. So theoretically it should be 36, right? But now we have only 28. But potentially this one also can include the false positive. False positive means background proteins. However, we detect this is kind of the significant one now, right? So from here, I just want to double check. So from SIG skyline, what is the unique ID of proteins? So because I want to check actually all the significant protein actually are from our spiking protein or something else. Here we go. So here the 6 proteins have any significant comparison. So so except this, other 6 protein is what we expected. But here is background proteins, right? And then any comparison will be some significant. Then what we can do, we can go back to the profile plot, or we can just double check actually how it look like. So here, how can I extract 6 skyline? 6 skylines protein ID is equal this. So here for this proteins, for condition 1 versus condition 2, yes, actually they have a huge difference. And then actually yes, so the just p-value also less than 0.5 and so on. Then commonly what I do, I just go back to the profile plot and then just check these proteins and then manually see actually this is correct or not. So this is kind of the what I just double check for group comparisons. So is it okay for so far the group comparison part? So in summary, after we got the data set, we use tool-specific processing computer function like Skyline to MS format or any one of these, and then go to the data processing, and then go to the group comparison. So if you just summarize only 3 functions, it's very simple. However, between here, we use the visualization function, and then here also visualization function, and then we can get a p-value for our group comparison. So this is what we talk about so far. And then actually I make a branch, means we can go to any direction, any other downstream statistical analysis can be applied. Like group comparison is one of this. And here, data processing, we provide two different data. If we can go back, like process data or run summarized data. So we use the run summarization data for group comparison, but that output can be used for any other statistical analysis. That is one of things, the quantification. So quantification means with the summarized data, that is run summarized data. If you have a technical replicate, and then if you want subject level or group level summarized, you can use this quantification. With this, what you can do some classification of analysis, like what Olga mentioned this morning, biomarker study, or like some logistic model or PCA or something else. You can use this output for another analysis, or like some cluster analysis and so on. So we are going to use this one for clustering or classification analysis on Wednesday morning. And then based on this group comparison, we can calculate the sample size for further experiment. We need this output because we can calculate the variance component from this group comparison functions. So based on the variability which calculate from here, we can use the design of the sample size functions. So last, we'll talk about the design of sample size. So here, sample size calculations. For sample size calculation, let's do not test sample size. The function name is design sample size, and input should be test guideline and fitted model. So test guideline have three different data sets, and then here comparison result can be used for visualization, but for sample size, fitted model data should be used. So fitted model, and if you remind ourselves of what we did for intro R, when you calculate the sample size, we also set up the alpha value, beta value, and then desired forward changes, some variability, right? So here, variability can calculate by the fitted model, but other things we have to give them this number, very specific numbers. So one is that is FTR 0.5, and then power we just 90%, and then desire for change we can give some range.
Is that 1.6?
Yes, 0.6, yes. Then, how the sample size look like? Here, this is the table. So it has, based on each desired for change, this is the sample size calculation for 5% FDR and then 90% power and so on. So for example here, if you desire for change is 1.4 with 5% FDR and then 90% power, you need the 3 samples per conditions. So this is the table, but you also can calculate, make a plot, design sample size plot. So not design sample size, a classification plot. We are gonna plug this one on Wednesday. This is a design sample size plot, and then sample size. It will not make a PDF, but it will draw it here. So just summary of the table. So if your desire for change is 1.2, go up, and then here around the 10 is your required sample size. Okay? And same as the power calculation what we practiced last week. This is very simple. So I will just copy this. But instead of sample, I will change this to power. We can calculate the power too. So to calculate the power, this one should be null. So I will not give you the power, which means just give me the power calculation. However, I need to give the number of the sample. Oh, here, okay, not null, it should be true. Sorry. Then power. So now power column have a different value with the same number of the sample size. So we can also draw the plot here. If you have a 3 replicate, and then this is the FDR, here is the power. So around the 1.4, we can have the 90% of power, and so on. Okay. Then I briefly show how can you get the quantification for sample or group. So from run summarization, we can also get some subject level or group level quantification. I will call subject quant is there's a function quantification. The input is our output of the data processing. And then how it look like. For each protein, each group and subject ID they provided. In our experiment, we have only one biological replicate, like basically one subject for one condition. So now it like one condition, we have only one value and one conditions. However, if you have a multiple biological replicate, you can see multiple column from the one conditions. And then same thing, group, count, same function, skyline. However, we can type here based on group. Then, if I check here, now it looks same, but the column name is different. Now it's condition 1. There's no -1. So condition 1, condition 2, condition 3, and 4, they have a group like they'll summarize the value. So you can use this value for any further analysis, and then you can use especially some other statistical analysis for genomics based on genomics. So you can use that one also for your further analysis.
So does it do the median of the replicates?
Across the replicate, I think the median, but I need to double check. Yeah. Then last, what I want to address, we try to multiple things, and then there's a folder. I want to introduce two types of the file. So we never made this one automatically. It was generated. One is a session info. It shows your R version, and then what kind of the version of the software you use. Here, MSstats 3.12 and something else. Like any kind of the R and package related information here. It is very important for your record. And another one is MSstat log file. So now we can see there are two log files. This one includes a little bit more information. So first is same as the session info. What R version you use, what version of the package you use. Definitely you need to mention this version ID in your manuscript, definitely, because as you see, MSstat version 3.10.6 and then version 12, the filtering stage is different. We got the different number of the rows, right? Different number of the rows, different number of measurements, slightly maybe the result can be different, right? Definitely we need to mention about this. And then based on step by step, actually it's recorded. For example, actually the first they check it, like all the input is correct or not, what kind of summary method you use, what kind of option you use, and then they actually check in, is this okay, and sub intensity is 0, we replace something, and then here's the balance is okay, normalization, we use this normalization, and then here's the experiment design, and then here's the answer. So first, this is very important for your record. Second, if you have an error, this is kind of the tracking document. So somewhere is a stop. It will be stopped here, and then we can easily find where's the issue, and so on. So for this 2 point, this is quite important. So this thing is whole workflow for MSstat, main MSstat part. But tomorrow, Wednesday, we are going to talk about a little bit other branch, another side of the analysis for MSstat. And then also we have another, tomorrow maybe Olga will talk about it, like some assay characterization or quality control and so on. We will not cover that part during the program. However, if you are interested, please let us know. Any one of our member can help you this part. So we have 30 minutes left. So what I can suggest, you can go over from the statistical analysis part, like group comparison part, for OpenMS input, and then you can actually compare how actually the final result will be different. Because now we know the 36 comparison and the protein should be different, right? And then we found like around the 27 and 8 is we can find as a significant as skyline. However, you can find how many you can find in the OpenMS, and then how much accurate in the for the estimate for changes. So for rest of 30 minutes, I recommend to try to run everything from OpenMS. And then tomorrow morning, I will be here from 8. And then I heard that one of the people want to know how we can go through for Spectra now for DIA case. I will briefly talk about that one in the morning. And if you have any specific question or topic you want to cover, please write in your note or just let me know. And then I will post what kind of topic I will cover tomorrow morning from 8 to 9. Okay? So from now on, I will walk around and then please practice and please let me know if you have any questions. One more thing, Piazza, the Q&A, and then here stat folder. There's a MSstats TMT installation, and then here is a R script to install MSstats TMT. So please try to run now or later, but before tomorrow. And then if you have an issue, please let us know.